right, so I'm going to pick up right where I left off with essential question 3 here. Remember, I'm going to focus in on these top 2 objectives. So the slide that I last left off was the one that had you look at the oxygens and the calcium's masses. And if you notice that, I'm going to flip back to that real quick, that when we look at the atomic mass, say, of oxygen, and then even the molar mass, say, of oxygen, they both have that same number. So what's really nice is that they are numerically equal. The only difference then is the unit. So when we are looking at, so if I say I want the atomic mass, I need the unit to be AMU. If I'm going to say I want molar mass of something, then I want it to be grams over mole. So just a quick clarification on that. So I would write that down. Atomic mass, AMU. Molar mass, grams per mole. So when we look at determining the mass of a compound, so in nature, we're going to deal with lots of compounds. We're not just going to have elements. So we're going to need to know, how do you determine the molar mass of a particular compound? So say you have the compound of water. So just think a moment, how are you going to go about determining the said molar mass of this particular compound? When you're ready, continue on with this video. So how are you going to do that? You're simply just going to add up the atomic masses of all of those atoms that make up this particular molecule. So having your periodic table in front of you here now, if you locate the element of hydrogen, you'll see that it has a mass of 1.008. And then if you look up oxygen, you notice that it has a mass of 15.999. So we're just going to add them up. But here's the tricky part. There's 2 hydrogens, so I need to make sure that I have added 2 hydrogens worth of the mass. And so here on my next slide, I have simply showed it to you. So I took 2 times the mass of said hydrogen plus the mass of said oxygen. And if I said I want the atomic mass of it, I would have an answer of 18.015 AMU. If I said I wanted the molar mass of this particular compound, I could say 18.015 grams per mole. Now I know that my mass of hydrogen is just slightly different right at the end. It just happened to be the periodic table that I had in front of me as I was making up these notes here. So let's try out another example. I would like for you now that I've tried that first one here, I want you now to please pause the video here in just a second to determine what would be the mass of this particular compound, Mg3N2. All right, now that you are back, here is your answer. So we would have an answer of 100.93 AMU. Or if we were looking at molar mass, we could say 100.93 grams per mole. Now, I'm not going to be too much of a nitpicky person in terms of significant figures, so you don't have to worry about that for this particular section. But I will ask, though, don't round. Please just write down the whole thing that your calculator reads. So I know oftentimes people want to try to round, but please do not. Just write exactly the way that your calculator reads. And in this example, I most likely probably did round, and that's an error on my end, but I'm going to ask for you, please, to not round. So here's a third example. I'd like for you to try out this particular one. We have AlCl3. So go ahead and pause this video and try this one out. All right, now that you're back, here is your answer. We would have 133.341 AMU, or if I was looking at the molar mass, we would have 133.341 grams per mole. Now I'd like for you to try this particular compound. So we have Ca3, and then in parentheses, PO4 with a 2 on the outside. So think about what we just did right at the beginning of this unit, looking at how many atoms you see. And I'd like for you now to try this particular compound out. So pause the video, try it out, and then push play and get the answer. All right, now that you are back, and here is your answer. I would have 310.174. And again, I wrote both units just there depending on which particular example it was that I was asking for you to determine, grams per mole or AMU. So this is what the first two objectives happen to be for this particular essential question. And here ends the notes. Thank you.